Hello and welcome to Gaffy's Grinds. Before we begin, you should turn your phone on silent, close any open tabs, and when I ask you questions, make sure that you do them. In our previous video, we looked at how surface area of a substance affects the rate of a chemical reaction. In this video, we're going to look at something similar, but instead of surface area, we're going to look at how does the temperature of a substance affect the rate of a reaction. So let's begin. Here is a box, a container. So this here is a container. Okay, and here are some particles. So I've got some red particles. I've got some blue particles. And these just mean different substances. So the different colors, particles are different substances. And they are moving around in random directions. So I'm going to show this using these motion lines. So these motion lines show me that they are vibrating and they are moving in random directions. That's what particles do. These arrows are going to show the direction that they are moving. So this one here, this blue one, is moving from up to down, and this red particle here is moving from left to right. Now, for a reaction to take place, we know that particles must collide. So here are two particles. They are moving in different directions. A reaction cannot take place even if they have enough energy, even if they have the activation energy. A reaction cannot take place if they don't collide. Now, let's look at these two particles, this one and this one. So here are two particles, and now they have collided. They've collided, but they do not have the activation energy. So these two particles have collided, but they don't have not enough energy. Okay, and if they don't have enough energy, then we say that the reaction or the collision is not successful. So just to remind it, if we don't have the activation energy, which is the minimum amount of energy that particles have to have in order to have a successful collision, then no reaction will happen. This is called the activation energy. So we've seen that two things must happen. Particles must collide and they must have enough energy. Let's look now at these two particles. This one and this one. These two were moving very, very fast. So when they collided, they had the activation energy. And what that means is this yellow thing I'm drawing around is just showing that there's enough energy. So this here has been a successful collision because the particles collided and they had enough energy. So underneath, for a successful collision, particles must collide. That's the first thing. And number two, they must have the activation energy. Is needed. If you've got both of these things, then you have a successful collision, and then a reaction can take place. All right, it's time for you guys to do some practice questions. So over here, we've got questions 1 to 5. What I want you to do is pause the video, answer the questions in a copy, then when you're ready, press play. Okay, so you should only be watching if you have completed the question. So for a reaction to take place, sorry, I've double typed that. I'll just fix that mistake. Apologies about that. For a reaction to take place, particles must, so the two missing gaps here are going to be, they must collide and they must have enough energy. Well done, if you got that right. What do we call this minimum amount of energy? So we would call this the activation energy. Hope at this stage that's quite straightforward. We've done this a couple of times. So make sure you either tick them or fix them. What will happen if the particles have enough energy, but they do not collide? So they do have enough energy, but they never collide. Then they won't react. It won't react. Very simple. If they don't collide, they can't react. What will happen if particles collide, but they don't have enough energy? Well, then they just bounce off each other. They do not react. You can see particles can have one of the two things. They can have the activation energy but not collide, or they can collide and not have the activation energy. If they don't have both of these things, then no reaction takes place. Suggest how more energy could be transferred to the particles. So I know my students, by the time you watch this video, you will have learned about energy and how we can transfer energy to substances. So if we have a substance, how could we add more energy to particles in a container? Okay, we do this by heating. So well done if you said that. Notice the word here was to suggest. So I haven't actually told you this yet, but it's kind of a little bit common sensey. So I thought that some of you might have been able to suggest. We are going to see that now in a second, but heating is how we would do that. Well done. If you got that right, good job. All right, let's move on to discuss temperature then, because that's what we're supposed to be doing, remember, looking at the effect of temperature on the rate of a reaction. Okay, so let's say, I'm just going to rub all this out, this right in. Sorry. Just clearing some space here. Let's say that this here is a container with particles at a lower temperature. Lower temperature. If this is the particles at a lower temperature, we've seen this collision here is not successful because the particles don't have enough energy. This collision over here, or these two particles with the arrows moving in different directions, that's also not successful because they don't collide. So how can temperature affect this? Well, if we were to take this container and we were to increase the temperature, and again, in the last question, we saw how we would do that. We do this by heating. So this is supposed to be a flame. Okay, so we increase the temperature. What does this do? This transfers energy to the particles. So transfers heat energy to the particles when we heat it up. This increases the temperature to the particles. So we transfer heat energy to the particles. How is that going to have any effect? Well, over here, let's draw the container again. I want to say this is the container at a higher temperature. Now we won't have changed the particles or the amount of particles or anything else about them. They'll still be the same size. So I'm going to draw some of the particles. I'm going to try and draw them in the same place so that it's equal amounts of particles. There we go. So we've got the same amount of red particles and we're going to put in the same amount of blue particles. There we go. How are these particles now different from the way they were before? They're different because all of the particles, or a lot more of the particles, will have gained a lot more of these motion lines. So as you can see, the particles, because they have more energy, are going to be moving around the container a lot more and a lot faster. Okay, so this is the container at a higher temperature. So what impact does this have? Well, if the particles have more energy, what effect is this going to have on the reaction? It's going to affect the reaction in two ways. Okay, in two ways. So we've got two arrows here. Affect it, the reaction in two ways. First of all, the particles, if they have more energy, are going to move faster. If they are moving faster, then this is going to make them collide more frequently. Frequently. And remember that this word frequent just means often. How often? So if they're moving faster, they're going to collide more frequently. The higher temperature also means that the particles have more energy. So they're moving faster because they have more energy. Sorry about that. I had to pause because I had a low battery. Now, we said the particles are moving, they have a more energy. So this means that they move faster and they will collide more frequently. It's just like if I put some students into a room and I blindfold them and I ask them to walk around the room, like I put like 5 students in a room and I say walk around the room with a blindfold on. Eventually, 1 or 2 of them might bump into each other. But if I blindfold you and ask you to sprint really quickly around the room, then you're much more likely to crash into somebody a lot quicker. So again, if you're moving faster, you're going to collide more frequently. Particles having more energy, though, also means that a higher amount of the particles, or what we say, a higher percentage. So a higher percentage of the particles, because they have more energy, they have the activation energy. So that if they do collide, it's much more likely to be successful. Okay, so a higher percentage of the particles have the activation energy. So temperature is going to affect the reaction in two ways. First of all, it's going to make collisions more frequent. It's going to make particles collide more frequently. And the second thing, it means that a higher percentage of the particles have at least the amount of energy required, the activation energy, in order to react. So these two things together, what do they do? Well, they increase the chances of successful collisions. So they increase the chances of successful collisions. Okay, so these two things together increase the chances of successful collisions. And if you increase the chances of successful collisions, it means you increased the rate of reaction. Really simply, expressing the relationship, we would say if we increase the temperature, then we will increase the rate of reaction. That is the relationship of reaction. That is the relationship between temperature and rate of reaction. So it's important to be able to state it's important to be able to state this relationship, but that's not enough by itself. You have to be able to explain why. So you have to be able to talk about the collisions, the energy, and how frequently the collisions happen at different temperatures. All right, ready to do some more practice questions? Let's have a look. All right, so again, I want you to answer these questions in the copy. I want you to pause the video and play again when you're finished. Okay, so let's have a look at what you've got. 2 containers, different particles, so the 2 containers, the particles are at different temperatures. Okay, so it says in which container will the particles move more quickly? So the correct answer here is B. Particles move more quickly in B. So well done if you said B. How do you know? Well, particles are at a higher temperature. What does that mean? That's not enough to just say higher temperature. Why does that make them move? Why does that mean that they're moving faster? Higher temperature, this means the particles have more energy. And if they have more energy, then they're going to move faster. Okay, so higher temperature means particles have more energy. So obviously I'm only giving you the stuff you must have in your answer. You should have a full sentence, but it should include these things. So make sure you do include these things. Next one, how is the temperature changed from 21 to 55? How would you do that? So hopefully it said something here about heating. You heat it up or you warm it up. So heating is how we increase the temperature. We add more energy by heating. How will the particles moving faster affect the frequency of collisions? Okay, so there will be more frequent collisions, or a higher frequency of collisions. More frequent collisions. So they happen more often. So you should use frequency or frequent in your answer. More frequent or higher frequency of collisions. Okay, next one, in the box, in which box are the particles more likely to have the activation energy? Well, that would definitely be B. How do you know? Well, because the temperature is higher. Temperature is higher. What does this mean? It means they have more energy. If even more energy was transferred to the particles in container B, what would happen to the temperature? Well, it would increase. More energy was transferred, temperature goes up more, so it would increase. And describe the relationship between temperature and the rate of reaction. So here's it in short. Higher temp means higher rate. And again, I would expect you to have a sentence or a paragraph built around that. So higher temperature means a higher rate of reaction. That's what we're talking about. That's the relationship. Right, let's have a look at a graph. How does this look on a graph? So if we were to try and draw a graph for how rate affects the rate of a reaction, I'm just going to get out my ruler. I'm going to start by drawing an X and a Y axis. So here is my Y axis, and here is my X axis. And as usual, when I do a rate of reaction graph, sorry, my OneNote has crashed. I'll have to pause this video and go back. Sorry about that. So when we're drawing a rate of reaction graph, we will plot time on the X-axis. So we look at as time progresses in the reaction. So time on the X-axis, usually measured in seconds. And on the Y-axis, we're going to put some kind of an amount. So we're watching the amount of the reaction of the reactants or the products or concentration. In this case, we're going to use volume of gas produced. So say a reaction is producing a gas as a product, we're going to look at volume of gas produced on the Y-axis. So this is our product being produced. It's a gas product. And sorry, that's really bad. I'm just going to try and fix this so it's a little bit neater of a box. There we go. Okay, and we're going to show our reaction happening at two temperatures. So I'm going to show it in a blue line first of all, and the blue line is going to show the first box up here, the reaction at the lower temperature. So what do we know about what's happening here? Well, we know that the collisions are happening less frequently and less of the collisions have enough energy. So the rate is going to be a bit slower. So as you can see, this curve, the volume of gas being produced is going up, but the graph is not really steep. It goes up and it starts to slow down and eventually it levels off and it stops changing. So there is our lower temperature, our reaction rate for the lower temperature. This is the blue line. We're now going to show you the rate of reaction for the faster temperature, or the higher temperature, sorry. As you can see, the red line increases much more quickly. So the rate is much faster. The line is steeper. And what you can see is it starts to level off, and it actually levels off and the reaction finishes before the blue line. It becomes level before the blue line. And that's because the reaction is over earlier, because it's quicker. So all of the reactants are used up quicker and the reaction finishes earlier. So the red line shows the higher temperature. Higher temperature. All right, so let's just quickly break down this graph, show what we've got. Okay, here is the slope of the blue line. The slope of the blue line here is a tangent, and as you can see, it's a shallow slope. Shallow slope. The shallow slope means slower rate. Here is the slope of the red line, and as you can see, the tangent line is much steeper. This here is a steeper slope. Steeper slopes mean faster rates. Faster rate of reaction. We also see that the red line finishes quicker. So we say the reaction finishes quicker. Whereas the blue line only becomes flat here. The reaction finishes slower. Apologies again, my OneNote has been very glitchy today. Yeah, so we were just working just right here, and we said that this arrow shows where the blue line becomes flat, and this shows us that the reaction finishes slower. So it takes longer for it to be finished, whereas the red line finishes back here, becomes flat. The reaction is over back there. So that are the differences between a higher temperature and a lower temperature. That's how it affects our rate of chemical reaction. Let's have a look at a couple more questions to do with those rate of reaction graphs. All right. So what I want you to do is I want to pause the video and answer the questions to 1 to 5 and play when you're finished. All right, so you should only be watching if you have answered the questions. And a reminder, if you're not going to answer them, if you're going to sit and listen for me to tell you, then you're not wasting your time watching the videos, you're not going to learn anything. Okay, so when a curve on the graph is steep, what does this tell you about the rate of the reaction? So steep graph means the reaction is fast. So it's a fast reaction, or the rate is high. A high rate or a fast rate. How does the rate of any reaction change as the reaction proceeds? Well, on all of our graphs so far, we've seen that it's very steep in the beginning and then it becomes slower. So the rate slows down. So it starts fast and it slows down. What has happened to the rate of the reaction when the curve becomes flat? The reaction has stopped. And if the reaction has stopped, then the rate is equal to 0. There is no rate. It's not doing anything anymore. To make the curve less steep, how would you change the temperature? So thinking about, okay, I'm going to make the curve less steep. That means I'm going to lower the rate, and I would do that when the temperature is cooler. So what would I do? How would I change the temperature? I would reduce it or lower it. Reduce the temperature. And lastly, explain your answer to question 4. So how does reducing the temperature make the curve less steep? Okay, so lower temperature. What does that mean? If I have a lower temperature, it means particles have less energy. Okay, so lower temperature means the particles have less energy. So what? What does that mean? Collisions are less, keyword coming up, frequent, or they happen less often. So you should definitely mention the frequency of collisions, and a lower percentage of them have the activation energy. So a lot of them don't have enough energy when they collide anymore. So you don't get as many successful collisions. All right, so that would be a very good answer, explaining your answer to question 4. Lower temperature The particles have less energy, collisions are less frequent, and a lower percentage of them have the activation energy. All right, that's going to do it for today's video on how temperature affects the rate of a chemical reaction. Okay, so guys, if you found the video useful, do leave a like and maybe comment down below if you want me to do a video for you in the future, or tackle a topic for you, and I'll see you in the next one.